Welcome students. So now let's discuss the operation of the timer modules in 8051 microcontroller which has been configured in mode 2. So in general the mode 2 operation of the timer modules in 8051 is preferred when we go for implementing or when we go for waveform generations mostly. Okay, even though we can use this particular mode for generating delay, since we know that the specialty of mode 2 is that it has the auto reloading feature. So this feature is most useful, or it is most beneficial when we go for waveform generation. So let's look to the first example. Here we are requested, or it is needed to generate, or we are in the need to generate a symmetrical square wave at port P1.0 or the pin P1.0 with T on and T off is equal to 256 microseconds using timer 0 of 8051, which is configured in mode 2, and the 8051 microcontroller uses a crystal of 12 megahertz. So with respect to the discussions that we had in mode 1, we know that when we are using a crystal of 12 megahertz, the time period of the internal clock pulse that is applied for the operation of the timer will be 1 microseconds. So with respect to the maximum equation of the maximum delay which can be obtained for each of the modes, considering the equation for mode 2, where the maximum delay is defined by time period of the clock pulse, that is 1 microsecond, multiplied by 256 minus initial value. Okay, so if we are initially loading the count value 00, the maximum delay which can be obtained from the mode 2 operation is 256 microsecond. Okay, so here the count value should be loaded to the count register is 00. Okay, so and the other peculiarity is that we need to load the value to the th0 or thx register, uh, and from this register a copy of the value will be automatically loaded to the TLX register or TL0 register in this case. Whenever we turn on the transistor or turn on the timer, or whenever there is an overflow of the uh, timer overflow flag. Okay, so let's look into the program. So initially we perform the instruction move tmode comma #002h, which configures timer 0 in mode 2 operation, and after that, as we had discussed, the count value which has to be loaded to th0 register is 00. So I am copying that value 00h to th0 register. Now since we need to generate this symmetric square wave at p1.0, I am setting the value of p1.0 initially, which makes a logic 1 at the output, or which outputs a logic 1 to this particular pin, and after that I am calling the subroutine named as delay, and after that I am again clearing the port pin p1.0, and again I'm calling the subroutine, and I need to repeat this process, so I'm just writing sjump loop. Okay, even though there are different methods, we are just following the same syntax, not syntax, the same template which we have used for generating the waveforms in all the cases which we had discussed in the previous classes. Okay, so here you can see both the value to the T mode and THO register, TH0 registers are mentioned in the main program. So when we are comparing to that of the mode 1 program, where the count value was always mentioned inside the subroutine, here we are writing that particular value in the main program. That is, a one time loading of the count value is enough, and whenever we call the subroutine, and when and you can see that when you go to the subroutine, initially the first step is to turn on the timer. At this instant, the value which is being loaded to the th0 register will be automatically reloaded to which a copy of that particular value will be automatically loaded to the TL0 register. Okay, so we turns on the timer and we checks whether the overflow flag is set. Okay, and we will be waiting at this point, and once TF0 equal to 1, it will be coming out, and we will be clearing the timer flag, as well as we will be stopping the timer, because we doesn't need the timer to be auto reloaded, and the counting should not repeat further, because the required delay of 256 microseconds is obtained here itself. Okay, after that, using this return instruction, we will be going back to the main program. Now let's check the execution or this particular flow using the simulation. So I'm initially burning or not burning, I'm building the program. There are no errors and warning. I'm going for debugging. So when I debugged, I entered to the debugging mode, and here I'm taking the peripherals timer 0. Okay, so you can see the window here. So I'm using the logic analyzer, which can be used. So I'm setting the port as P1 port 1.0. Okay, and I'm changing the value to bit state. Okay, now I'm just running this initially. Okay, I'm just showing that implication. So I'm going to run step by step. So first, on executing the first step, the configuration value 02 is loaded to the T mode register, and you can see that timer 0 is now configured to the 8-bit auto reload mode. Then on executing the next step, the value is now copied to TH0. Since initially all the registers will be 0, here you cannot see any difference. Then I'm going to set the value of P1.0. Okay, so that is made 1, and after that I'm going to call the delay. Okay, so check here, when I call the delay, it comes here to the subroutine, and I'm going to turn on the timer. So set TR0. So I'm turning on the timer, and you can see here, as soon as I turn on the timer, the value in the TL0 register is now incremented. Okay, now as long as it is been running, you can see the value is only changing in TL0. You know, there is no change for TH0. Okay, that is what we have already mentioned in mode 2. The copy of the value that you're loading to the TH0 register will be available in TL0, and that will be incremented. Okay, so the programmer can configure the value using the TH0 register, and on executing, that value is preserved, and the value copied to the TL. A copy of that particular value is copied to the TL0 register, and the controller is going to make alterations on that. Okay, now if I turn on the logic analyzer and I'm going to continuously run the program, you can see that I'm getting that particular square wave generated. Okay, so here you can see that for each and every overflow, the timer flag is getting uh, set and it is being cleared, and similarly we are stopping the timers also. We may not be able to see that because the delay here is 256 microseconds, which is very small for our eyes to distinguish. Okay, so that's regarding the first case. Now let's discuss another type where we have the timer, where we the time Azure mode 2 operation is optimized or is used effectively. Okay, so here the let us consider the second question where we need to generate a symmetrical square wave at p1.0, and it has a frequency of 50 hertz, and here it is mentioned that you need to generate this square wave of this particular given frequency using timer 1 of 8051, which is configured in mode 2, and the 8051 is now interfaced with a crystal of 12 megahertz. Okay, so corresponding to the 50 hertz, if I calculate the period, I will be getting 1 by 50 hertz, which is equal to 0.02 seconds. That is the total time period of the symmetric square wave that has to be generated at port 1.0 is now having a period of 0.02 seconds. Since it is symmetric, for logic 1 we need to have a width. The pulse width for logic 1 will be 0.01 seconds, and for logic 0 it will be another 0.01 seconds, which makes the total period of the square wave 0.02 seconds. So we know that for using the mode 2, the maximum delay that is possible is 256 microseconds. So we need the delay of 0.01 seconds. So if we divide 0.01 seconds divided by 256 microseconds, we will be obtaining the value as 39 times. That is, the delay loop of 256 microseconds should be repeated 39 times, so that I will be obtaining a delay of 0.01 seconds. Okay, so the first instruction here is configuring the timer 1 in mode 2, so I'm loading the value #20h. And since I need to repeat the maximum delay that is possible in the mode 2 39 times, I'm loading the initial value as 00 to th1 register. Then I am setting the port to pin p1.0 and I'm calling the subroutine, and again I'm clearing it, and again I'm calling the subroutine. Okay, and I'm using the sjump loop so that this process will be repeated again and again, so that I'll be getting a symmetric square wave of frequency 50 hertz. Okay, so when we come to the subroutine, you can see here that I need to repeat it 39 times. Okay, so I'm writing move r0 comma #39, that is a count maximum, the count how of for how much time I need to repeat. Then I'm turning on the timer, that is set btr1, and I'm waiting for the overflow flag to set. Okay, once it is set, I am just clearing the overflow flag. Okay, and after that what I'm doing, I'm just checking whether r0 is 0. Okay, so it is not 0, then I am again going for rechecking. So what happens here, once I clear this one on overflow, the value will be resetted to 0. Okay, and I'm going to clear this. At the meantime, parallelly, what happens, the value th that was loaded to th1, that is 00, has been loaded to tl1, and its execution has been started again automatically. Okay, and what we are doing is that we are checking the value for r0, whether if it is non-zero, I need to check the status again and again. That means I need to check 39 times. Okay, so if the overflow flag is set, or the value of if the value of the overflow flag becomes 39 times, then I can make sure that the delay has been repeated. Okay, the 256 microsecond delay which is obtained, the maximum delay which is obtainable in mode 2 has been repeated 39 times. So that is what I'm doing using this instruction. Okay, once I find that 39 times the flag has been set, then I'm coming out and I'm stopping the timer, so that the required delay after one status, that is set b p1.0, has been achieved. And after that, after clearing, I'm again calling, so again this same thing happens. So here you can see that in this case also, we will be just loading the value to the counter register th1 initially in the main program for the only once. Okay, we are not loading that value repeatedly in the subroutine. Okay, so that is a so this makes a difference between mode 1 and mode 2, or any other mode of operations in the mode 2 from any other modes of operation that is supported by the timer modules in 8051. Okay, so if I save this and if I burn, okay, and if I go for the debugging stages, and you can see here, so instead of timer 0, I'm using the peripherals timer 1, and I'm going for continuous running. Okay, so sorry, so if I go for continuous running, you can see the waveform is coming. Okay, so if I take, I can see I'm getting that square wave generated. Okay, so this is how you can obtain. Now to make it little bit clear, I'm going to change the value. It's not for 50 hertz. I'm just going to change the value here as some fd. Okay, so that you will be getting that, you can clearly understand that particular auto reloading feature, okay, which is happening here. So if I go for debugging right now, and here you can see I'm not going to check the waveform, that is of least importance for me. Okay, I can also use the other method, that is register view. So if I execute the first line, timer 1 is now configured to 8-bit auto reload mode. Then second step, th1 is loaded with the value fd. Then I'm setting the value of p1.0 as 1. Okay, and I'm calling the delay loop, so it comes here. Now r0 is loaded. On execution, r0 will be loaded with the x value of 39, that is 27, and you're going to start the timer. Okay, now you can see if I go next, I'm waiting for timer and ft gets incremented. Okay, so the value th value will be now loaded. So you can see that it gets th1. Okay, so if I go for the continuous running, you can see that I am getting that waveform again. Okay, for every FD that increment. Okay, so initially that particular value was just copied. So for every overflow that is happening here, you are getting that set value. Okay, so with that we are winding up the session on programming the timer module of 8051 microcontroller in the mode 2. Okay, so in the next class we will be discussing about the other modes of operations, or we will be continuing with the interrupt section. Okay, thank you.